All right, we've looked at how to find volume if it just involves one function. It's just pi r squared. If you got two functions and we're using that washer method, it's pi r squared minus pi r squared, and you get the volume there. What happens though if you get a problem that looks like this? Find the volume of the solid obtained by rotating the region R enclosed by the curves of y equals x and y equals x squared. So nothing looks different here, but here's where we come in something different. Rotated about the line y equals 2. We've always rotated around the x-axis before, and now they're asking us to rotate around y equals 2. So how do we handle a problem if it's not the x-axis? Well, what we're going to have to do then is adjust what our functions are going to be. So let's start with our volume function here. It's going to be the integral. If we look at these two functions, x and x squared, there's the region enclosed by those. We can see it's going to be an integral from 0 to 1. So nothing has changed there. Pi times our radius, which is the distance between these squared minus, since there's two functions, pi r squared minus pi r squared. So we're going to have these two functions squared, and it's going to be in terms of, or our width of those, or height of those cylinders is going to be dx. And we're going to have these two radiuses squared here because it's pi r squared minus pi, which was factored out, squared again. So what we got to figure out is what are those going to be. Had it just been around the x-axis, it would have been easy. It would have just been x and x squared. But now that we're rotating about the line at y equals 2, our functions are going to change here. So let's look at what this is now. So if our new rotation line is 2, the radius of these circles now has changed. So here's the center of this circle. Our radius is from the center to the outside here. What is that length going to be? Well, to find that, we are going to use the fact that we know that distance is 2, because that's around the line y equals 2. And we're also going to use the fact that we know the distance between the bottom of this function right here in the graph, that would be x squared. And so if we want this distance, or the radius distance there, that would be the difference of those. That radius would be 2 minus x squared. So it'd be the longer length minus the shorter length would give us this radius, which is the difference. So that would be the radius further away from our rotation line. If we do something similar for the inside one, our inside radius is from the center to right here now. We don't know what to call that, but we again know this length here ends up being 2. The distance from here to here, which on this picture that's a little closer here, that's this distance, that would be y equals x. And so if that's x and this is 2, this would be the difference of 2 minus x, and that would be our inside radius right there. So you have to do some subtraction or adding when doing that. Here's kind of a better picture of this. Here's the center of our circle. So we know from here to here, that would be our value of x squared. Here to here would be that outside radius, which would be 2 minus x squared, because we know that distance is 2. And then same with the inside one. All right, so then the evaluation of that, then we know how to do. You could use calculator or something to evaluate and get your answer. But the setup is the part where you got to do some adding or subtracting whenever this line would change.